Hello everyone, welcome to PW Gulf. So today is the time for the ultimate recap session of the chapter Motion in a Plane. We have done the recaps of previous chapters. I hope you all have watched them. Today we'll be doing the chapter Motion in a Plane in a single shot. We'll be revising all the important formulas of the chapter. So let's see what we'll be covering today. First, we will define motion in a plane, that how we define the position, velocity, acceleration of a particle when it is moving in a plane that is in two dimensions. Okay, then we'll be going on to projectile motion. Projectile motion is a special case for two-dimensional motion. We'll be doing two types of projectile motion: angular projectile and horizontal projectile. Then we'll be going to relative motion in two dimensions, the Rainman problem and riverboat problem. Okay, so let's start a chapter motion in a plane. So how we define a plane? When we define a straight line, it is having a single dimension. But if we define a plane just like this board or this sheet of paper, anything, the floor, everything is a plane. Okay, it has two dimensions. It has two dimensions. We can call the one dimension as x and other dimension as y. So this is a plane, 2D plane. Now if my particle is situated at any point P, which is x comma y, in the plane, then how we define the position? First we'll set up a coordinate system. Then we will draw a position vector. Okay, then we will draw a position vector from origin to that point where the particle is situated. Now in single dimension, we have one positive and the other direction as negative. Is this, if this is positive, this is negative. We have only two directions, this or that. But when we move in a plane, we have infinite directions. Okay, each is a different direction. We have infinite directions in a plane. So we make use of vectors to define the motion in a plane. Okay, that's why we make use of vectors to define the motion in a plane. So to study motion in a plane, vectors is a prerequisite. Okay, so I hope you have watched the lecture of vectors. Then you can shift to this lecture. Okay, now if this is my particle's position x comma y, draw a vector from the origin to that point. This vector is called position vector. Okay, this vector is called position vector. Now what are the coordinates? If this point is having the coordinates x comma y, then this point will be x and this point will be y. Okay, this point will be y. So how can I define my position vector? My position vector r will be equal to xi cap plus y j cap. Okay, it will be equal to xi cap plus y j cap. Suppose if we have 2 points x1 x2, x1 y1 and x2 y2, we have 2 points and we have to define the position vector from one point to another. Okay, just like this. If we have 2 points like this, x1 y1, and this point is x2 y2, and we have to define a position vector from x1 y1 to x2 y2. Okay, this is my displacement. Particle displaced from position p1 to position p2. Then what will be my displacement vector? Initial position to final position. So I can write my displacement vector as x2 minus x1 I cap plus y2 minus y1 j cap. Okay, displacement in x, how much the particle has displaced in x direction. From x1 it went to x2, so displacement in x will be x2 minus x1. This is displacement in x and direction is I cap. Displacement in y, from y1 it went to y2, so displacement in y will be y2 minus y1 j cap. We can also write it as delta x I cap plus delta y j cap. Okay, this is our displacement vector, and this is how we write the position vector. Okay, this is the position vector of the particle. R vector is called position vector. Okay, R vector is called position vector of our particle. Now let's see how we define velocity of a particle. Now velocity is rate of change of position in a particular direction or displacement by time. So if we have to define average velocity, okay, if we have to define average velocity, it will be total displacement, or if total displacement by total time, okay, it will be total displacement by total time. So from this we will get that V average is equal to delta x by delta t I cap plus delta y by delta t j cap. Okay, this will be my velocity. But if we want to write instantaneous velocity, okay, if we want to write instantaneous velocity, now we know that instantaneous velocity is the differentiation of position. Now differentiate a position vector, this will become dx by dt I cap plus dy by dt j cap. So this dx by dt, will give me velocity in x I cap, and dy by dt will give me velocity in y into its direction, that is j cap. This is how we define the velocity in two dimensions. Now where my Vx, what is the value of Vx? Vx is equal to dx by dt. What is the value of Vy? Vy is equal to dy by dt. Okay, Vx is equal to dx by dt. Velocity in x is equal to rate of change of x coordinate. Okay, velocity in y will be equal to rate of change of y coordinate. This is how we define the velocity. It will also be a vector because particle is moving in two dimension. It has two components of velocity, one along x and the other along y. Now let's see how we define acceleration. Now we know that if I have to write average acceleration, this will be equal to total change in velocity by total time. So it will be delta v vector change in velocity by change in time. Now if we have to write it in component form, it will become delta vx by delta t I cap plus delta v y by delta t j cap. This will be my velocity, okay, where delta vx is the change in velocity in x direction and delta vy will be change in velocity in the y direction. But if we have to define the instantaneous, okay, if we have to define instantaneous acceleration, then what will be my instantaneous acceleration? It is the rate of change of velocity vector. Okay, sorry, it is the rate of change of velocity vector. Now substitute the velocity vector, it will become dvx by dt I cap plus dvy by dt j cap. This will be my rate of change of velocity vector. So I instantaneous will be equal to ax I cap plus ay j cap. Okay, will be equal to ax I cap plus ay j cap, where our ax is equal to dvx by dt. Acceleration in x will be equal to rate of change of velocity in x, and similarly acceleration in y will be equal to rate of change of velocity in y. Okay, so this is how we define the motion of a particle in two dimensions. When it is moving in two dimension, both the coordinates x and y are changing simultaneously. So we have a velocity in x, we have a acceleration in x. Similarly, we have a velocity in y, we have a acceleration in y. Okay, now let's do the special case of motion in a 2D, or example of motion in a 2D, that is projectile. Now what is projectile motion? Suppose we throw a ball into the space, okay? Suppose we throw a ball into the space. It is given some initial velocity. Then is there any force which is acting on the particle? We threw a ball. So we have a girl, okay, or a boy, anyone. We have a child, okay. This child kicked the ball, okay. This child kicked this ball, and this ball followed a trajectory like this, okay. This child kicked the ball, and ball followed a path like this, okay. Kicked the ball and ball followed a path like this. It moved like so. When my ball is moving like this, is there any force acting on the ball? Is there any force acting on the ball? Yes, there is a force which is equal to mg, weight of the ball, okay. There is a force which is equal to weight of the ball, which is acting on the ball at every point, okay, which is acting on the ball at every point of its motion. Is there any other force than the earth's gravitational force? Is there any other force? No. There is nothing other than mg. There is nothing other than mg. So when a body moves under the influence of gravity alone, that is, body is moving only under the gravitational attraction of earth, no other force is acting on the body, then the motion of such a body is called projectile motion, okay. Then motion of such a body is called projectile motion. So projectile is the name given to any body which once thrown into space, okay, which is once thrown into space with some initial velocity, okay, with some initial velocity, then it moves under the influence of gravity alone, okay. It is moving under the influence of gravity alone, no other force is acting. So not being propelled by any engine or fuel, no other force is acting, nothing is driving this ball or projectile, then such a motion is called projectile motion, okay. And this ball is called projectile, or the object which is thrown is called projectile, and the motion of such a object is called projectile, okay. The object which is projected is called projectile. So example of projectile, yes, when we kicking a football, or when a player smashes a six, okay, when a player smashes a six in the cricket, okay, six in the cricket is a football. When a player throws a javelin, okay, when a player throws a javelin, javelin is also following a projectile path. Javelin throws six in the cricket, rest. Bullet fired from a gun, okay, bullet fired from a gun. All these are examples of projectile motion, okay. When you hold a water jet, water is also moving under the influence of gravity alone, okay, after being thrown with some initial velocity or flown with some initial velocity. All these are examples of projectile motion. Now let's see how we study projectile motion. So before studying the projectile motion, there are some assumptions that we made to study the projectile. What assumptions we made? We assume that there is no air resistance. We know that when we throw a ball in the air, air puts a resistive force on the ball, okay. Ball experiences a resistive force in air, or air is dragging the ball, we can say that, okay. But in projectile motion, we assume that there is no air resistance, okay. Air is not dragging the ball, there is no air resistance. Then we know that earth is having a spherical curvature, okay. Earth is not a flat, it is a spherical in curvature. But when we throw a projectile, see, when we throw a projectile, if it goes from here to here, just throw a ball in your room, what you will see, that is it moving on a curved surface or a flat surface? So we assume that the range of the projectile or the distance covered by the projectile on earth is very very less than the radius of earth, such that this portion of the projectile is moving only this much portion on this big earth, then it will be looking like a flat surface whenever we throw a ball. See how ground looks like, it looks like flat or spherical, flat, because this distance is not that much greater to experience the curvature. So we, the effect due to curvature of earth is negligible. Okay, we assume that there is no effect due to curvature of earth. Next point is, we know that as we move above or below the surface of earth, value of acceleration due to gravity changes. Okay, the value of g changes with height, but we assume that the body is going to some height h, which is very very less than r. Okay, this h is very very less than r, such that acceleration due to gravity remains constant. Okay, such that acceleration due to gravity remains a constant. Okay, so we assume that effect of height is not that much that g will change. For all points of trajectory, acceleration due to gravity is constant both in magnitude as well as direction. Okay, we assume that g is a constant. Clear? These are the assumptions we made to study projectile motion. Now, when we do motion in two dimensions, we have already studied motion in one dimension, and we saw that it is very easier to study motion in single dimension rather than in two dimensions. So what we did is, we divided our motion into two directions. We very well know that if I have a force F acting like this, then this, in this direction, component of force will be F cos theta, and component of force in this direction will be F sin theta. So we have divided this F into two components. Similarly, if we have velocity, we can divide velocity in two dimensions. If we have acceleration, then we can divide acceleration in two dimensions. So what we do is, we separate the motion in two mutually perpendicular directions. Okay, we separate the motion of the particle in two mutually perpendicular directions. Now we know that two mutually perpendicular directions do not influence each other. Okay, so a velocity in x can only be changed by acceleration in x. Okay, similarly a velocity in y can only be changed by acceleration in y. Okay, if we put a force, if we have a particle like this and Vx is along this, now put a force, the particle is subjected to a force in y, their velocity in x will not change due to force in y. Only velocity in y will change due to this force. Okay, only velocity in y will change, Vx will remain the same. So this is called principle of physical independence of motion. So the two motions of projectile along horizontal and vertical directions. Okay, so motion is divided into two mutually perpendicular directions. One is horizontal direction and the other being the vertical direction. Okay, so we divided the motion into two directions, one horizontal and the other vertical. Now these are two mutually perpendicular directions, so motion is independent along these two directions. Okay, motion of the object is independent along these two directions. Okay, along these two directions. This is called principle of physical independence of motion, that motion along x is independent of the motion along y, and motion along y is independent of the motion along x. They are not dependent on. Okay, so let's study the project. Now projectile can be of two types. One is angular projectile and the other is horizontal projectile. So when we fire any object or project any object at some angle with the horizontal. Okay, when we project any object at some angle with the horizontal, like this, okay, or like this, at some angle with the horizontal, then motion of such a projectile is called angular projectile. Now we will be studying ground to ground angular projectile. Okay, a body is fired from the ground at some angle and it reaches the ground. So we will be studying ground to ground projectile. We'll be studying ground to ground projectile. So if I have a body and it is projected with some velocity u at an angle theta with the horizontal, then this body will follow a path like this. Then this body will follow a path like this. Okay, so at every point of the body, the force acting on the body is only mg, that is weight of the body. Okay, this direction is called x and this direction is called y. Okay, we will take this direction as y and this direction as x. Now what is angular projectile? When any body is projected into air with some initial velocity at an angle theta, where theta is not equal to 90 or 0. Neither the theta can be 0 nor theta can be 90. We cannot project like this, we cannot project like this. Okay, so we cannot project the body in x and we cannot project the body in y. It is projected at some angle theta with the horizontal. So such a projectile is called angular projectile. Okay, such a projectile is called angular projectile. Now divide the motion of this projectile into two directions. If velocity is having angle theta, so component in x will be u cos theta, component in y will be u sine of theta. So x component is u cos theta and y component is u sine theta. Now write the components in two different directions. So along x direction and along y direction. Okay, along x direction and along y directions. So what is my initial velocity in x? Initial velocity in x is u cos theta and initial velocity in y is u sine theta. What is my acceleration is x? Is there any force acting in x direction? Is there any force acting in x direction? No. At every point only mg force is acting, or we can say that it is having acceleration due to gravity g downwards. Okay, acceleration of the particle is only g downwards. So acceleration in x is 0, acceleration in y is minus g. Okay, it is acting downwards, it is minus g. So this is the, now let us take that any time t particle is at point p x comma y. At any time t it is projected at t is equal to 0 and at any time t particle is at point p x comma y. So displacement in x, displacement in x, displacement in x will be from 0 it went to x and from 0 it went to y in y direction. So displacement in x will be x, displacement in y will be y. Okay, displacement in y is y. Now let us calculate the parameters associated with this projectile. Okay, now what is trajectory of the projectile? What is trajectory of the projectile? The path followed by the projectile is called trajectory of the projectile. Okay, the path which is followed, so this, the path which the projectile is following, this path is called the trajectory of the projectile. Now we know that at any time t, Sx is equal to x and Sy is equal to y. Now we know that in x direction motion is independent. Okay, in x direction motion is independent of the motion in y. So Sx will be equal to uxt plus half ax into t square. Now because ax is 0, we have a uniform motion in x direction. Okay, as we know that ax is 0, we have uniform motion in x direction. Particle is moving with uniform motion in x direction. Okay, so sx is equal to uxt plus half axt square. Now this is 0, so x will be equal to u cos theta into t. So at any time t, what is my particle's position in x? At any time t, what is the particle's position in x? It is u cos theta into t. Similarly, sy is equal to uy into t plus half ay into t square. So sy is y, uy is u sin theta into t minus half dt square. Okay, so this is my particle's position in at any time t. Okay, this is the particle's position in y direction. If I ask particle is thrown from the region, find the position at t is equal to 1. So x position at t is equal to 1 will be this, and y position at t is equal to 1 will be this. Now if we have to find the displacement, so displacement will be under the root of x square plus y square. That is displacement in x square in x plus displacement in y. This will give us the displacement. Now when we have to find the trajectory, trajectory is a relation between x and y, because trajectory is the equation of this path. Okay, trajectory is the equation of this path. So this path is a curve in xy plane, so trajectory is a relation. Path followed is the by the projectile is trajectory. It is a relation between x and y. What we will do is, from x is equal to u cos theta into t, can we write t is equal to x divided by u cos theta? Substitute this in y, so we will get that y is equal to u sin theta into x divided by u cos theta minus half g x divided by 2 cos theta whole square. So from here we will get that y is equal to u and u get cancelled out, x tan theta minus g divided by 2 u square cos square theta into x square. So this will be our equation of the particle's trajectory in xy plane. Now if we rearrange this, okay, if we rearrange this, write it in a better form, write it in like this: tan theta into x minus half u square cos square theta into x square. Now write it as y is equal to ax minus bx square. So this is the trajectory of the particle. This is the equation of trajectory. The equation of trajectory of the projectile. Now see, what is this equation? This is a quadratic equation. This is a quadratic equation, general form of a quadratic equation. Now we know that for quadratic equation, the path followed will be a parabola. Okay, the path followed will be a parabola. So trajectory is following a parabolic path, or we can say that equation of trajectory is a parabola. Okay, equation of trajectory is a parabola. It is following a parabolic path. Okay, so now we have done the equation of trajectory. Let's see the time of flight. Now what is time of flight? The time of flight is the time taken to complete the whole journey, that is from ground to ground. Total time the projectile spends in air is called the time of flight. Okay, it is time taken by it from the instant it is projected to the time it reaches the surface again. That is the time of flight. Okay, that is the time of flight. So if we have a projectile which is fired like this. Okay, so at t is equal to 0, particle is here, and at t is equal to capital T, particle reaches again the same surface. So in time t, Sy is 0. From 0, again the y coordinate is 0. So in time t, Sy is 0. So time of flight is denoted by capital T, and this capital T comes out to be 2u sine theta by, okay, use the equation that when time t is equal to capital T, Sy will become 0 when time is capital T. So use the equation Sy is equal to uyt plus half ay into t square from, so let us do it. In time t, Sy becomes 0. So Sy is equal to uyt plus half ay t square. So 0 is equal to u sine theta into t minus half gt square. Okay, minus half gt square. So from here we will get that t is equal to 2u sine theta by, okay, from here we will get that t is equal to 2u sine theta by g. This is the time of, okay, this is the time of flight of the particle. Now see, the particle's path is exactly symmetrical. It reaches the midpoint. Okay, it reaches the midpoint, that is maximum height. At maximum height, velocity in y will become 0. That's why it is not going more upwards. Vy will become 0. That's why after that particle is not moving in y direction more, it starts coming down, that is Vy has become 0. So at this point Vy becomes 0. So first the height is increasing, then the height is decreasing. This first time is called time of ascent, and this time is called time of descent, and the total time is called the time of flight. So time of flight is equal to time of ascent plus time of descent. Now time of ascent is exactly the half the time of flight, and it is equal to 2u sine theta by g divided by 2. So it will be u sine theta by g. Similarly, time of descent will also be u sine theta by, okay, time of ascent is sine theta by g. Similarly, time of descent is also u sine theta by g. And time of ascent is equal to time of, okay, time of ascent is equal to time of descent. Now let's do the next parameter, that is horizontal range. Okay, if this is my projectile, the distance it travels in the x, or displacement, sorry, the displacement it travels in the x, this is called the horizontal range. Okay, this is called the horizontal range. Now this distance is being traveled in which direction? In x direction. Okay, so the horizontal distance traveled by the projectile during its time of flight, that is from t is equal to 0 till t is equal to capital T, the displacement done by the projectile in x direction, horizontal direction, is called range. Okay, horizontal range. Now horizontal range is denoted by capital R. So from the formula, use Sx is equal to uxt. Okay, in time capital T, we got that Sx is equal to R. Sx is equal to R when time is equal to capital T. So from this we get that R is equal to u square sine 2 theta by t. Okay, we get that R is equal to u square sine 2 theta by g, and we can also write it as R is equal to 2ux into uy by, okay, can also write it like this. When we open this sine 2 theta, this will become 2 sine theta cos theta. So we can rewrite it like this. Okay, r is equal to u square sine 2 theta by g, or 2 ux into uy by g. Similarly, time can also be written like this. Okay, similarly, time can also be written like this: 2 uy by g. Okay, 2 into uy by g. Initial velocity in y by. Now let us move. These formulas are very, very important. Let's mark them as star. Okay, let's mark them as star. This is our horizontal range. Let us do the maximum height. The maximum height which the projectile reaches in its whole journey is called the maximum height. So the maximum vertical distance attained by the projectile above the plane of projection is called maximum height. Now if this is my projectile, again x and y, this is my projectile like this, then this maximum distance which the projectile attains, this is called the maximum height h. Okay, it is denoted by capital H. Now at the point of maximum height, Vy will become 0 and Vx will become, velocity will become like this, tangent to the path, and Vy will become 0. So Vy will become 0 when we have Sy is equal to H. When we have Sy is equal to H. So use the equation Vy square minus Uy square is equal to 2ay into Sy. V square minus U square is equal to 2as in vertical direction. We will get that H is equal to U square sine square theta divided by 2g. Okay, H is equal to u square sine square theta divided by 2g, or in other way we can write it as uy square divided by, okay, can write it as uy square divided by e. So these are maximum height and in the theta form and in xy form. Okay, in xy, uy square by 2g, this is our maximum height. Now let's find the velocity at any instant t. See, if this is my projectile, okay, if this is a projectile and we have to find the velocity at any instant t. At any instant t, it will have velocity v, which is a tangent to the path. Okay, so this, there will be two components of this velocity, vx and vy, and the angle which this velocity makes with the horizontal is called theta. Initially the projectile is fired with some initial velocity u at some angle theta. So velocity in x will be cos theta and velocity in y will be u sin theta. This is my initial velocity. At any time t, particle is at here. Particle is at t is equal to 0 at the origin, fired, and then at any time t, particle is at this point t. So the two components, now Vx will be equal to ux plus ax into t. Now ux is 0. So any time t, Vx is, oh, sorry, ax is equal to 0. So this factor becomes 0. At any time t, Vx is equal to, okay, at any time t, Vx is equal to ux, or we can say that Vx is always equal to u cos theta. Velocity in x is a constant. Okay, velocity in x is a, velocity in x is constant. Okay, velocity in x direction is a constant. Uniform motion we have in x direction. Okay, particle is executing uniform motion in the x direction. Similarly, Vy will be equal to uy plus ay into t. So from here Vy will be equal to uy minus dt or Vy will be equal to u sine theta minus y will be equal to u sine theta minus gt. This is the velocity at any time t. Now, if we want to find the angle with the horizontal, these are two components. Take tan of beta. This is our v vector. This angle is beta. This is Vy and this is Vx. So, if we take tan beta will be equal to Vy by Vx. From here, tan beta will be equal to u sine theta minus gt divided by 2 cos. Tan beta will be equal to u sine theta minus gt divided by u cos theta. This will be our tan beta, angle made by the velocity in time at any time t. Angle with which direction? Horizontal. Now let's find the velocity at the point of striking, that is at the final point. Let us find the velocity at the final point. If this is my projectile and we fired it like this, at t is equal to 0, projectile is here. At t is equal to capital T, projectile is here. We want to find this velocity, okay, this final velocity. So this velocity will also have one component along x, one component along y, and the angle made by this with the horizontal will be beta. Okay, initially it is making an angle theta with the, this is our u vector initial velocity theta. So velocity in this direction will be u cos theta and in this direction will be u sine of theta. Now let us see that Vx will be always equal to ux, which is always equal to 2 cos theta, and Vy is equal to u sine theta minus g into t. Now time at the point is time of light, 2 u sine theta by g. So we will get Vy is equal to minus of u sine theta, that is at the final point. At the final point, Vy is equal to minus of, okay, at the final point, Vy is equal to minus of uy. And if we write the speed, speed will be under root of Vx square plus Vy square. So speed will be equal to initial. Okay. Final speed will be equal to initial. Final speed will be equal to initial speed. Now calculate tan beta. So from this tan beta will be Vy by Vx. It will be minus Uy by Ux. Okay. Let us do it over here. Tan beta will be equal to Vy by Vx. So tan beta will be equal to minus uy by ux, and uy by ux is equal to tan theta. So it will be equal to minus of tan theta. From here we get that beta is equal to minus. Okay. From this we get that beta is equal to minus theta. So the projectile will strike the ground with the same speed. Okay. Projectile will strike the ground with the same speed as it is projected. Okay. It will strike the ground with the same speed at a same angle. But this angle is called minus theta because theta is like this elevation and anti-clockwise direction, and beta is like this, okay, clockwise direction. So beta will be equal to minus of theta. Okay, this is our parameters of angular projectile. Now let us move forward and see that condition for maximum horizontal range. At what angle the particle will have maximum horizontal range? Now we know that range is equal to u square into sine 2 theta by t. Now range will be maximum. Okay, r It will be maximum when sine 2 theta is maximum. When sine 2 theta will be maximum, then r will be maximum. What can be the maximum value of sine 2 theta? Sine 2 theta can have the maximum value as 1, which means 2 theta is equal to 90 degree, or we have that theta is equal to 45 degree. Okay, or we have that theta is equal to 45 degree. So at theta is equal to 45 degree, range will be maximum. Okay? Range will be maximum. Now let us see that complementary angles of projection. For complementary angles of projection, what will be our range? What are complementary angles? Complementary angles are theta and 90 minus. These are complementary angles. Now for theta angle, range will be u square sine 2 theta by g. And for second angle, complementary angle, range will be u square sine of 2 into 90 minus theta by g. So this will be R2 will be equal to u square sine of 180 minus 2 theta by g. Now we know that sine of 180 minus x is equal to sine x only. So from here we will get that R2 is equal to 2 square sine of 2 theta by g. What we got is R1 is equal to R2. What we get is R1 is equal to R2. So the range, horizontal range is equal for complementary angles. If the particle is projected with same speed u at an angle 30 degree and then at an angle 60 degree, same speed, then range of the two particles will be equal. Okay, range will be equal. Now let us do horizontal project. Now, what is horizontal projectile? If we are standing at some height, okay, if we are standing at some height, h, and we throw the particle horizontally, okay, and we throw the particle horizontally, only giving a horizontal velocity, it will come to ground following a path like this. So, this is called a horizontal projectile. After throwing, at every point only acceleration is mg force is acting, so only acceleration is acceleration due to gravity. So this is called a horizontal projectile when we throw the particle horizontally. In this case, let us resolve the motion in two directions, x and y direction. So in x direction, what is my ux? X direction is having the velocity u. What is my initial velocity in y? No, nothing. Nothing is given in y, only velocity is given in x. We throw the particle like this, okay, horizontally. Acceleration in x. What will be your acceleration in x? It is 0. No force is acting in the x direction, and acceleration in y will be minus g acting downwards, okay, minus g acting downwards. So these are the parameters or resolution of the motion in direction. Now let us obtain the same parameters for horizontal projectile also. What is the trajectory of my projectile? So at any time t, what will be my x? It will be equal to ux into t, because ax is 0. Okay, let us take it as sx is equal to uxt plus half ax into t square. So x will be equal to u into t. Okay. At any time t, displacement in x will be ut. Displacement in x will be ut. Similarly, sy will be uyt plus half ay into t square. So y will be equal to, uy is 0, so it will be minus half gt square. Okay, y will be minus half gt square. These are the values of x and y at any time t. At any time t. Now let us define the equation of trajectory. So from this we can write it as t is equal to x by u. Substitute in the second equation, we will get minus d by 2 x square by u square. Write in the form it is minus d by 2u square into x square, or we can say that y is proportional to minus x square. This trajectory is of parabola. Okay, this is a again a parabola. Y is proportional to, okay, x square, sorry, y is proportional to x square. So this is a parabolic path. Okay, trajectory follows a parabolic path, and this will be our equation of. Now what this negative sign signifies? Negative sign signifies that it is moving in downward direction, y. Okay, displacement y is in the negative y. Okay, it is along minus y direction. Now time of flight, again in time of flight, what, how much displacement particle has done? From h height it has come to 0. So displacement in y will be minus h. Okay, displacement in y will be minus h, and we get the time of flight as under root of 2h by, okay, we can get the time of flight as under root of 2h by the root of 2h by g is our time of flight. How can we find it? We can find it using, sy is equal to minus h when time is t is equal to capital T. To use the equation of sy, we will get. Now what is horizontal range? Okay, this distance which the particle travels before coming to ground, this is called the horizontal range. Okay, this distance which the particle travels in the horizontal direction before coming to ground is called the horizontal range. Now range, this in time t is equal to capital T, sx is equal to r. From 0 it has gone to a distance r in the x direction. So from here range will be equal to under root of u times under root of 2h by g. Range will be equal to under root u times under root of 2h by g, or r is also equal to u into capital. Okay, r is also equal to u into capital T. Now let's find velocity at any instant t. Again, velocity at any instant t, vx will be equal to ux plus ax into t. Now because ax is 0, vx will remain as at every point of the trajectory. At every point of the trajectory, horizontal velocity will be ux only. Okay, if we project the particle from a height h with initial velocity u, the path followed by the particle will be like this. So at any point of time it is having velocity v, which is having a x component and a y component, and the angle made by this velocity with horizontal is beta. So vx will be equal to u only, vy will be equal to uy plus ay into t. So from here uy will be equal to, how much is uy? It is 0. Uy is 0. So it will be minus g. Okay, it will be minus g. So at any time t, vy will be minus gt. What is my tan of beta? So tan of beta will be equal to vy by x. From this, tan beta will be equal to minus gt by, tan beta will be equal to minus gt by u. These are the velocity at any instant. This is the velocity at any instant t. Now let us find the velocity when it strikes the ground. Let us find the velocity when it strikes the ground. If the particle is projected from a horizontal height, from a vertical height h, path followed by particle is like this. So at this point velocity will be tangent to the path like this. It will have a x component and one y component, and angle with the horizontal will be beta. Now substitute the values. Vx at every point will be equal to uy only, and vy will be equal to minus gt, because particle will reach here after time t is equal to capital T. So vy will be equal to minus g into under root of 2h by g, or vy will be equal to minus of the root of, okay, y will be equal to minus of under root of 2g, okay, under root of 2h. And again find tan beta. So tan beta will be equal to minus the root of 2gh divided by u. This will be our tan beta will be vy by v. This is the velocity at the point of when it is striking the ground. Okay, velocity at the point of striking the ground. So this is all about horizontal projectile and projectile motion. Okay, I hope this is clear to you. This is the projectile motion. Now when we move in two dimensions, okay, when we move in two dimensions, suppose we have two particles which are moving, and one moving particle is observing the other moving particle. Okay, one moving particle is observing the other moving particle. So position vector of 2 with respect to 1. Okay, we have to define the position vector. So now how will that particle see as the observer? Okay, if this is my xy plane, this is my xy plane, and I have two particles. Have two particles. One is having p1 at coordinate x1 y1. Okay, one is having p1 coordinate x1 y1, and the other is p2 having at any instant t coordinate x2 y2. Okay, at any instant t they are having the coordinates p1 as x1 y1 and p2 as x2 y2. Now this will be my position vector of the coordinate. This will be my position vector of the coordinate 1, and similarly this will be my position vector of the coordinate 2. So this is our r1 vector and this is our r2 vector. Now when we are observing the motion from 1, okay, position of vector 2 with respect to 1, when we are observing the motion from 1, what will my second particle see? Okay, what will my first particle see? It will see itself at the origin and then measure that. When I am observing, how will I observe? I will observe that the chair is at 10 meters from me. The table is at 2 meters from me. So I take myself as the origin and then measure the particle's position. So when my 1 is the observer, 1 will draw its position vector like this. 1 will draw the position vector like this from itself to the position of the particle. So this is the position vector of 2 with respect to 1. Okay, this is the position vector of 2 with respect to 1. Now apply triangle law of addition. What we will have is r1 plus r21. R1 plus R21 should be equal to R2. So from here R21 will be equal to R2 minus R1. And what is my position vector of 2 with respect to 1? It is equal to R21, which is equal to R2 minus R1. Okay, which is equal to R2 minus R1. This is how we define relative position. Okay, this is how we define relative position. If we differentiate it once, we will get velocity of 2 with respect to 1. It will be v2 minus v1, and if we differentiate it one more time, we will get that acceleration of 2 with respect to 1 will be a2 minus a. Okay, this is the velocity of 2 with respect to 1. This is the acceleration of 2 with respect to 1. This is how we define relative motion in 2 dimensions. Okay, this is how we define relative motion in 2 dimensions. Okay, now let us move to some special problems of the relative motion in 2 dimension. One of them is the rain man problem. Okay, when it is raining, when it is raining vertically downwards, okay, when it is raining vertically downwards, how we hold the umbrella? How we hold the umbrella when it is raining vertically downwards? We will hold the umbrella upright. Okay, we will hold the umbrella upright like this. Okay, when it is raining vertically downwards, we hold the umbrella upright. When rain is coming at some angle like this, we will hold the umbrella like this to protect ourselves from the rain. Now when we hold the umbrella like this, because rain is coming again at some angle theta, so we will hold the umbrella like this. What are we observing in all the three cases? We are observing that we always hold the umbrella in a direction in which we see the rain. Okay, we always hold the umbrella in a direction in which we see the rain coming towards us. If I found that rain is falling vertically, I hold the umbrella like this. If I found that rain is coming at an angle, I hold the umbrella like this, similarly like this. So what direction we are holding the umbrella? We are holding the umbrella in a velocity of rain with respect to me. Okay, velocity of rain with respect to me. So in rain man problem, we have two persons. One is standing on the road and the other is moving. If rain is falling vertically, one will hold the umbrella like this. Okay, suppose we have a road. One person is standing vertically on this road. Okay, and rain is coming vertically downwards. Rain is coming vertically downwards. So this person will hold the umbrella like this. But on the same time we have a person which is moving on a cycle. Okay, we have a person which is moving on a cycle on the road. This is the person. Let's draw it. This is the person. It is moving with speed vm. Okay, it is moving with speed vm. Now rain has a velocity vr. Rain has a velocity vr. Man has a velocity vm. Will the man also see that rain is falling vertically downwards? Will the man also see that rain is falling vertically downwards? No. Man will see the rain. Man will observe the rain with velocity, with velocity, velocity of rain with respect to man. Now a moving person is observing the rain. So it will not observe the rain velocity as vertically downwards. It will see at some angle, because when we have two bodies in motion and one is observing the motion of the other body, then we use the concept of relative velocity. How I will perceive will be equal to PRM. How this man perceives the rain, it will be equal to velocity of rain with respect to man. So if this is the direction of vrm, okay, if this is the direction of vrm, if this is my direction of velocity of rain with respect to man, then this man will hold the umbrella in this direction. Okay, then this man will hold the umbrella in this direction. So in which direction man who is holding the umbrella? So man will hold the umbrella, any person. Okay, any person, any person moving or standing or sitting, man will hold the umbrella always opposite to, always opposite to velocity of rain with respect to man. Always opposite to velocity of rain with respect to man. Okay. Man will hold the umbrella always opposite to velocity of rain with respect to man. So we have a person in a rain man problem which don't know, which doesn't know in which direction he or she should hold the umbrella to avoid getting wet. We just have to tell the person in which direction he or she should hold the umbrella. So what we have to do is, ultimate concept is, we have to find VRM, because we will always hold the umbrella opposite to VRM. If VRM is downward, hold the umbrella upwards. If it is at an angle, hold it opposite to that. Okay, we always hold the umbrella opposite to VRM. So let's do the first case. Case 1, when rain is falling vertically downward. When rain is falling vertically, when rain is falling vertically downwards, so let us draw that. We have two directions. Have two directions. One will be like this and the one will be like. Now let us take this as the direction in any plane. Okay, that is any this plane in which we are moving. This is a direction in that plane. Rain is falling vertically downwards. Any direction in the plane will be perpendicular to the vertical. So we will have velocity of rain in this direction. Rain is falling vertically downwards with some velocity VR. Okay, so this is our velocity of, this is the velocity of rain, actual velocity of rain. Now we have a man. Man is moving with some velocity. Man is moving with some velocity Vm. Okay, man is moving with some velocity m in this direction. Now what will be my velocity of rain with respect to man? Velocity of rain with respect to man will always be Vr minus Vm. Now if this is Vm, draw minus Vm. If this is Vm, this will be minus Vm, will be minus Vm. Now what we have to do is, we have to add Vr and minus. Have to add Vr and minus Vm. So this will be our velocity of rain with respect to man. Okay, this will be our velocity of rain with respect to man, which is the vector sum of r and minus v, which is the vector sum of Vr and minus Vm. Now, if this velocity is making angle beta with the vertical, then we have to hold the umbrella at the angle, same angle, beta with the vertical, vertically opposite angle. This will also be beta. We will hold the umbrella opposite to VRM. This is will be our angle. Now we have to find beta. Okay, we have to find beta. Firstly, what will be the magnitude of VRM? Magnitude of VRM will be VR square plus Vm square, because angle between VR and Vm is 90 degree. So minus 2 VRM minus 2 VR Vm cos 90, that term will become 0. Now in this triangle, find tan of beta. Okay, find tan of beta. Tan of beta will be equal to Vm by R. So man will hold the umbrella at an angle beta, which is tan inverse of Vm by. Okay, man will hold the umbrella at an angle beta, which is equal to tan inverse of V by VR. So this is the angle with which man should hold the umbrella to avoid getting wet. Okay, now let's do case 2. is 2. When rain is falling at some, okay, when rain is falling at some, now rain is not falling vertically downwards, it is falling at some angle. Let us do that case. This is the horizontal, this is the vertical. This is the horizontal, this is the vertical direction. Now let us draw our velocity. Now if this is my velocity of, this is the velocity of rain. Rain is coming at some angle. Rain is coming at some angle theta with the horizon. This is my velocity of rain. Okay. Now man is moving in this direction. Man is moving in this direction with some velocity. Okay. Man is moving in this direction with some velocity Vm. Let us take this direction as I cap and this direction as j cap. Okay, this is I cap, this is j cap. Now if I resolve this Vr, resolve Vr into two components. Okay, resolve Vr into two components. Component in this direction, component in this direction will be Vr cos theta, and component in this direction, this component will be Vr sin theta, and this component is r cos theta. Okay. Now write the Vr vector. Write the Vr vector. It will be Vr sin theta I cap plus Vr cos theta j cap. Okay, it is our wish, we can also take this as minus j, and that is plus j, we can take it as minus j also. Okay, now write Vm vector. What will be my Vm vector? It will be equal to Vm I cap. Now what is my velocity of rain with respect to? It will be Vr vector minus, now substitute the above two vectors, we will get that velocity of rain with respect to man is Vr sin theta minus Vm I cap plus Vr cos theta j cap plus Vr cos theta j cap. So this is the velocity of rain with respect to man. What will happen? Vr sin theta minus Vm will left with be some Vr sin theta minus Vm in I cap and Vr cos theta in j cap. So what is a component? It will be R sin theta minus Vm in I cap and Vr cos theta in j cap. So my total velocity vector will be, this will be our VRM. Okay, this will be our VRM. Now if it is making angle beta with the vertical, then we will hold the umbrella. If this is making an angle beta with the vertical, then we will hold the umbrella at the same angle beta with the vertical. Okay, so now calculate what will be my tan beta. So tan beta will be equal to Er sin theta minus Vm divided by Er cos theta. So man will hold the umbrella at this angle when rain is falling at some angle. Okay, when rain is falling at some angle, this will be the angle with which the person should hold the umbrella to avoid getting wet. Okay, to avoid getting wet. So this is all about rain man problem. Now let's do the another problem, that is river boat problem. Now in river boat problem, we have a person. Okay, it is trying to cross a river of width d. Okay, it is trying to cross a river of width d. River is flowing with velocity r. Okay, river is flowing with velocity vr. Now here we have a velocity of man with respect to river. Okay, this is the velocity of man with respect to river. That is when river water is still. Okay, when river is not moving, river water is still, then man can cross this river with the speed vmr. This is also equal to velocity of man in still water. Okay, velocity of man in still water, this is also equal to velocity of man in still water. So when river is not moving, what is the velocity of man? It is vmr. Now when river is moving, then also man can only move with this much capacity. So what happens is, man starts moving at some angle theta. Okay, man starts moving at some angle theta with the vertical, with the velocity which is equal to velocity of man with respect to river. Okay, man starts moving with some angle theta which is equal to velocity of man with respect to river. Now we know that vmr is equal to Vm minus Vr. So from here, what will be my velocity of man from ground? So ground person will see that man is moving with velocity Vmr plus Vr. So when we are seeing from ground, see, this river flow will try to drift the man, and man will move with some velocity Vm in this direction. Actually, man will be following this path. Okay, river will be trying to drift the man. River flow will be trying to drift the man. So if an observer is standing on the ground, he will see the velocity Vm vector. Okay? If observer is standing, he will see the velocity Vm vector. Now we have to calculate and what time this man will cross the river and what will be the drift of the man. Okay, so first is time. Time taken to cross. So time taken to cross the river is what we are trying to calculate. So we have a river which is flowing with velocity r. The width of the river is d. Okay, width of the river is d. Now man starts moving at some angle theta with the velocity of man with respect to river. Now this direction, this velocity will have two components. This velocity will have two components. One is vmr cos theta, mr cos theta, and one other one is vmr sin theta. Okay, other one is vmr sin theta. Now if we see that velocity in vertical will be vmr cos theta, actually the man will be moving like this. Okay, actually man will reach a point. If it started from a, it will reach this point b. Okay, this will be the direction of velocity of man from ground. Okay, this will be the direction of velocity of man from the ground, and man in actual will reach the point b. So this change in change or displacement, initially it is at this point, finally it is at this point. Displacement in x. Okay, displacement along the river, this is called drift. Okay, displacement along the river is called drift. Now displacement in y direction is d. Speed in y direction is vmr cos theta. So time will be equal to d divided by vmr cos theta. Okay, time will be equal to d divided by vmr cos theta. This is the time which the man will take to cross the river. Okay, this is the time which the man will take to cross the river. Now let's find drift. Drift. Now this drift x. Drift is the displacement in the direction of flow of river. Now what is my displacement in x? Okay, displacement along the river flow is x, that is drift. What is my velocity in x? Man is having velocity. Velocity of man from the ground is VMR plus VR. Okay, VMR plus VR. So the river will impart its velocity to man. River will impart its velocity to man. So net velocity of man in x direction. Okay, net velocity of man in x direction will be VR minus VMR sine theta. It will be VR minus VMR sine theta because that is opposite. Time taken will be time taken to cross the river. This drift is obtained in how much time? This drift is obtained in time t equal to time which is equal to cross the river. So if river is crossed in t time, drift, it will crossed. It means it reached over here. After how much time it will reach? Time taken to cross the river. So we will have drift will be equal to x. It will be equal to VR minus VMR sine theta net velocity in x into the time taken to obtain that drift. Okay, time taken to cross the river. Now let's do a special case of this. Man wants to cross the river in shortest time. Okay, man wants to cross the river in shortest time. Now if the person wants to cross the river in shortest time, now time is given by t is equal to PMR cos theta. Okay, now time it will be minimum when denominator is maximum. So when cos theta is, okay, time is minimum when cos theta will be maximum. Denominator is maximum, fraction becomes minimum. So cos theta maximum, it means cos theta should be equal to 1 or theta should be equal to 90 degree. So angle with the vertical is 90 degree, or angle with the sorry 0 degree. Angle with the vertical will be 0 degree. Cos theta is 1, theta is equal to 0 degree. Angle with the vertical is 0 degree. So angle with river flow, angle with river flow, angle with river flow will be 90 degree. So if this is my river which is flowing with speed VR, this is my vertical. Okay, the man makes an angle theta with the vertical. Theta is 0, it means it should move with velocity VMR. It should move with velocity VMR in this direction. So angle with river flow is 90 degree and angle with the vertical is 0. And what will be the minimum time? What will be our minimum time? It will be d divided by VMR. So this is the case of minimum. Okay, this is the case of minimum time. Now let's do one more case, shortest path. Okay, shortest path. Now man wants to cross the river along the shortest. Man wants to cross the river along the shortest path. The shortest path is this D path only. The shortest path will be the perpendicular path. This D path is the shortest path. Any path, this or this, will be greater than. So shortest path is when it starts from A and reaches the exactly opposite end B. Okay, and reaches exactly opposite end B on the other bank, then this is the shortest path. Now if man starts moving with velocity PMR at some angle theta, then the component along this will be VMR cos theta and component along river flow will be VMR sin theta. River is flowing with velocity VR in this direction. When we have to take shortest path, we have to reach exactly opposite end. Okay, exactly opposite point. When we reach exactly opposite point B, drift is, what is drift? If I started from A and I reached B, then this this point AB, this distance is called drift. If B is over here only, drift will be 0. Therefore, drift is, now what is my drift? It is VR minus PMR sine theta into t is equal to 0. Now t can't be 0 because obviously it will take some time to reach the opposite end. So from here, VR minus PMR sine theta is equal to 0, or we can say that PMR sine theta is equal to VR. So sine theta is equal to VR by PMR. So at what angle man should move? At what angle man should move? Man should move at an angle theta with the vertical or perpendicular, which is equal to sine theta is equal to VR plus, from here sine theta is equal to VR divided by MR, or theta is equal to sine inverse VR by VMR. Okay. Now this is the angle with, this is the angle with vertical. Okay, this is the angle with the vertical or perpendicular. Angle with river flow, angle with river flow, angle with river flow will be 90° plus theta. Okay, so what is the angle with river flow? River is flowing in this direction, it will be 90 plus theta. Okay, angle will be 90 plus theta with the river flow. So this is for a case when the man has to take the shortest path. Okay, so this is all about motion in a plane. I hope you enjoyed the lecture as much I did, and you gained a lot from this lecture. We have revised the whole lecture in one attempt. Okay, so keep studying, keep rocking. All the very best. Thank you so much.